I wanted to walk through a few examples of what we did with integrating our solution into Openshift. We believe this is a good example of the types of tools that are critical when wanting to achieve success in large-scale enterprise implementations. So we'll take a few of the concepts and use our tool to demonstrate how these work in real life. So just a simple overview. What we have here is we have Openshift Origin Enterprise, and we've deployed a few applications. We've taken the kitchen sink application as an example. And this is an overview of what we have. So we do RC show. We can see that we have two applications, each with a JBoss cartridge and a MySQL cartridge. We set it to do auto scaling, so we have 2 gears currently in each one of these applications. And what we did was we took our technology and baked it into the platform, which means that without any changes to the application, the second you deploy your application into this, into our Openshift environment, you get better manageability and complete end-to-end visibility into that app, and this is what we'll see in a second. So what we'll do in the background is we'll launch up JMeter, and we'll run some loads through both of these applications. As you can see, KS1 is the first application, KS2 is the other. We're sending about twice the load into KS1 than we are into KS2. And we'll just let this loop for a while and start generating some traffic on our Openshift application. So with that, I'll switch over into SharePath. And the first thing we'll look at is our application dashboard. So let's take a look at some real-time monitoring. One second while we set it up. Let it run for a bit to gather some more information. Okay, so right now what we're seeing is we're monitoring the KS1 application within the Openshift platform. And what we see here is on the left, on the right-hand side, we see the response times. So without any change to the app, we're measuring every single response time from the end user perspective and from the first time it hit the platform. And we're measuring that and averaging that over the entire app. We can also see some transaction volumes coming in. So we can see which transaction volumes we're meeting versus exceeding the SLA. And then we classify all the requests coming in now through our script into different transaction types. So we'll classify them, and we can distinguish between a login and an index, in this case, a very simple application and a very simple script. What we're doing now is we're seeing this in real time. We're near real time, so we're at about a 5-second delay. On the left-hand side, you see the real-time topology and ties into what we discussed regarding real-time dependencies within the platform. So let's switch over to the topology map and see how is our application behaving. In this case, we see that indeed we've automatically picked up that we have 2 gears within the JBoss cartridge. We can see the Apache web server, which is essentially also serving as a load balancer. And we can see the MySQL database cartridge that we've added to this application previously. Now, if I take a look at the entire platform, so right now we're looking at a specific application, and now we've switched over to look at the entire platform. So right now we can see that in addition to KS2, it's very easy to now figure out we have another application, KS1, we can see the gears, and we can see the SQL database. So this is invaluable in terms of understanding where is traffic flowing right now. Notice, by the way, that one of these gears in the KS2 has a white line to the MySQL database. Essentially what that means is that it used to receive traffic, but for some reason, probably because we're not sending enough load, there's no communication now being done between that gear and MySQL. This is very useful for tracking configuration issues or gears that are not receiving any traffic, although they should. So the next view that we want to see is, if you recall, the JMeter was sending twice as much traffic than to one application versus the other. So I'll switch over to another view. All this information is being captured in real time. And what we'll do now is we'll take a look at the entire topology, and we'll say, show us this entire Openshift, which may be running 500 different applications. In this case, it's running 2. And show us how is our workload being segmented by these applications. So again, no prior configuration, just the fact that our developers have put in 2 applications into the platform enables us to get this bird's eye view of seeing how our applications are utilizing the resource. Now it's very clear one of them is taking about 70% of the load, and the other is taking a mere 30% of the load. But we can go in further and drill down to see how is the workload broken down within an application between the various gears and between the various nodes. So I'll break it down by node, and essentially what we see now is a complete breakdown by specific gears. This can be filtered out by cartridges. So for example, show us only PHP cartridges or show us only MySQL cartridges. In this case, we see all of them, and then it's very visible if we have one specific gear that perhaps is running background processes and is taking a lot of the resource. We can either separate it out, migrate it, or better architect our solution so that we're using the resource that we have more effectively. The last thing I wanted to show you is how granular this can be done and captured for a developer or a DevOps team. And essentially every single click of the user is now being tracked. So we now have a much better managed platform that can, the second a new application is deployed within Openshift, we can now capture individual user clicks, so a full audit trail of every user action that's been done. So here we see every single click in the KS1 for a very specific time frame. And we can also search only for ones that actually did not complete successfully. So in this case, we see only the ones that actually had errors in them. And we can see the exact response time that was done within KS1 now. It was 10 seconds. And then continue to drill down further and see the complete transaction segment. And complete transaction segment, who is the user, where it was sent, how long did it take, and then as you saw previously, go down to single lines of code to actually isolate it down. So this was a brief overview. The main concept is that the management is now baked into the platform. one of the toughest challenges that we see in getting people to migrate even to virtualization and shared resources is the question that says, how do you guys ensure that I'm going to have control over my own destiny in terms of application response time and availability? In many cases, people say, well, it's much more costly, but I'd rather just have my own hardware. Platform as a service gives you the agility and the self-service, and we believe that this is the main benefit of management, is being able to say, well, put your app on our platform and you will immediately get very, very advanced management and monitoring, ranging up from the platform down to the code level. So for the first time, both the ops team and the dev team can really communicate in the same language on the same data set, making the management and monitoring of the platform much, much, much more efficient than you would ever be able to get if you were managing standalone servers on your own hardware.